Welcome to Ask and Learn.
Hi, let's start the solution. In this question, we have given a linear mapping f r4 to r cube and fx, y, z, t is x minus y plus z plus t, x plus 2z minus t, x plus y plus 3z minus 3t. So note that it can be written as f x, y, z, t equal to x minus y plus z plus t and x plus 2z minus t, x plus y plus 3z minus 3t. So now f of x bar equal to ax bar, where x bar is x, y, z, t transpose. So now matrix A, write the matrix A. So matrix A is by comparing the coefficient of x, y, z and t. Then matrix A is 1, 1, 1, minus 1, 0, 1, 1, 2, 3, 1, minus 1, minus 3. So now by using Gauss-Jordan elimination method, elimination method, we reduce this matrix A in a row echelon form. So that means A equivalent to U, where U is a reduced echelon form. So now apply operation here, then we get R2 is R2 minus R1 and R3 is R3 minus R1. Then here we get 1 minus 1, 1, 1 first row as it is, second is 0, 1, 1 minus 2, this one is 0, 2, 2 minus 4. So now this is U. Now apply second operation. Second operation is R3 divided by 2. Then we get here 1 minus 1, 1, 1 as it is, first row, second row as it is. And this one is 0, 2 divided by 2 is 1, 1 minus 2, which is equivalent to this. So now apply R3 is R3 minus R2. Then we get 1 minus 1, 1, 1, 0, 1, 1 minus 2, 0, 1 minus 1, 0, 0, and this one is 0. Now apply R1 is R1 plus R2. Then here we get 1, 0, 0, 0, 1, 0. This one is 1 plus 1, 2, 1, 0. And here we get 1 minus 2 is minus 1, minus 2, 0. Thus, pivots are in the column of 1 and 2. So, first and second are the pivots positions. So, therefore, x and y are pivot variables and z and t are free variables. Now, by solving the pivots variable in a terms of free variables, we get x plus 2z minus t equal to 0, which implies x is equal to minus 2z plus t. And here we get y plus z minus 2t equal to 0. So that means y, this equation get here from here. So y is equal to minus z plus 2t. Now kernel of f is x bar belongs to R4 such that a x bar equal to 0, which is equal to x bar belongs to R4. A is equivalent to U matrix, U x bar, which is equal to 0. So therefore, all elements x bar belongs to R if x, y, z, t equal to minus 2z plus t, minus z plus 2t, and z and t are same. Then here we get, it can be written as z, take z common here, then write the elements of z, that is minus 2, minus 1, 1, 0 plus t, here we get 1, 2, 0, 1. So kernel f is kernel f equal to span of minus 2, minus 1, 1 0 comma 1 2 0 1. That is the value of kernel. Now we find the imaginary f. We know that imaginary f is equal to column space of A matrix. So since A is equivalent to matrix U and pivots are in the first and second columns of U. So therefore it follows that first and second column of A are a basis of column space A. So that is, we have imaginary of F equal to span 1 1 1 and minus 1 0 1. Here we write this elements from a original matrix. And next, find the dimension. Dimension of kernel F is 2 and dimension of imaginary F is also 2, because by the definition dimension is equal to number of bases. Here number of bases is 2 and here number of bases is 2. So dimension is 2, dimension of kernel is 2 and dimension of imaginary is 2. That is the answer. Hope you find the video useful. Thank you.